Okay, the next lab that you're supposed to do is to study capacitors. Now, whether you're using individual components that we have on the right, or you're using the circuit board on the left, either one will do. Here we have a few different capacitors. The ones on the right are a more typical normal capacitors. The one on the left is called a supercapacitor. Its capacitance is 1 farad. And it's limited to 5 volts. Do not put more than 5 volts across this thing. Now you can see that there's these two black lines here. That tells me that it's polarized. There's a longer pin over here, and that is actually going to go to the negative side of the battery. That's what that means. That's very important. You can also see how the the long pin, is connected to a metal plate, and the positive pin is coming through on an insulated material. Make sure you don't accidentally touch the positive pin to the large metal plate, or you'll short it out and you won't be using the capacitor. So I'm ready to connect the capacitor in series to the light bulb. I have the positive end of the battery going to this bulb, and now I need to get the other side of the bulb to the positive pin the capacitor. And you can see the alligator clamp is above the large metal plate with the rubber insulator over the alligator clamp. And now I'm ready to connect the negative side of the capacitor to the battery. Let's see what happens. Well, the light bulb lit up nicely, but it's definitely getting dimmer. And now it's going out. As the capacitor fills up, it gets harder and harder to put more charge in there. And eventually it acts like a break in the wire. Now after a little while, I've connected the voltmeter set on 4 volts in parallel to the capacitor, and I'm getting 3.175 volts across the capacitor. And I'm getting 0 volts across the bulb. Now I've disconnected the capacitor, and I'm going to measure the voltage. Okay. It's storing the charge while it's disconnected. Now we'll connect the capacitor to the circuit and see how it works. Ready? I'm going to touch it to the metal plate. So there's no batteries here. The capacitor is discharging through that light bulb. And you can see that we're losing our charge. It's diminishing, and the bulb goes out. Now that doesn't mean that there's no charge left on that capacitor. It just means that there's not enough voltage to light up the light bulb anymore. Yeah, as you can see here, we have it just measuring the voltage. So before we continue on with the experiment, what we want to do is discharge the capacitor. I'm just going to take the wire and connect it across the leads and let the charge run out. There is a little internal resistance inside these supercapacitors, so it will take a little while for this thing to completely discharge. And we're down. Now I'm ready to repeat the experiment, but I do not want to connect it directly. I want it to go through the meter so I can measure the current. I have to put the meter in series, and I'm going to have to change it from volts to amps. So now the current is going to go through the bulb, into the capacitor, out the capacitor, into the meter. It's set on milliamps, 400 milliamps, and then back to this connection on the negative side of the battery. So let's see what happens when I connect this. And we have about 200 milliamps. And the current is dropping off. The bulb is getting dimmer. So the meter is confirming exactly what we see with the bulb. Now even though that bulb is out, you can still see that there's current going through here, and it's still dropping as the capacitor builds up. Okay, the current is almost down to 0. I'm going to try to light the bulb with just the capacitor while measuring the current with the ammeter. To take the battery out of the circuit, I've just taken the one red wire, placed it over here to a blank pin, and I've got the same setup. I'm just going to connect it to the same pin and we'll watch the bulb and the current. Here it goes. Yep, we got that high current. And since it's set up the same as reading negative, because we're discharging the capacitor, the current's going the other way. So this is with the meter still in series because it's measuring current. Alright, just one last warning. Make sure that you have the long pin connected to the negative side according to that black line.